formation of photochemical smog. For starting this chapter, we have to know what is smog.
Photochemical smog. Photochemical smog is much more dangerous from ordinary smog. It is brown in color, observed in daytime in cities having high population densities. They are formed by photochemical reaction between a hydrocarbon, other air pollutant and particulates present in the atmosphere. During metabolic activities of plants, bacterial activity and anaerobic decomposition of organic matter, a large amount of hydrocarbon is emitted into the atmosphere. Most dangerous product due to photochemical reaction is peroxyacyl nitrate, PAN. Photochemical smog contains hazy fumes which irritate eyes and lungs, lead to cracking of rubber articles.
See over many cities. So it's a very clear indicator if you've got that brown haze there that you've obviously got that conversion of nitrogen into nitrogen monoxide occurring in car engines, and then the further reaction in the atmosphere in the presence of sunlight. So photochemical smog occurs when we have what's called a temperature inversion. So this diagram here is showing a temperature inversion. So normally as you go up from the surface of the earth, as you can see here, the temperature decreases as you go up, which is what you'd expect, okay, because there becomes, as the warm infrared radiation from the surface of the earth is radiated up, all right, it dissipates as it goes up, and so the air gets cooler. What happens with the temperature inversion is you've got your cool air here, and then you get this warm blanket over here of warm air. And what that does is that stops this cool air from, or the air from actually just going up and mixing. And so you get this, any pollutants or chemicals that are in here stay within this cooler air and they can't escape. So you get a build-up of chemicals within here. Now, that pollution, which builds up over here within this cool air, okay, is what leads to the presence of photochemical smog. Now, it's really important, obviously, that you have no wind, okay, because if you have no wind, that will stop this air from mixing. As soon as you get warm air, these start to mix and all the pollution starts to dissipate and you don't get your photochemical smog anymore. And we also need sunlight. Sunlight is actually a catalyst. That's why it's photochemical. It's a chemical reaction that relies upon the presence of light, and that helps speed up a lot of the reactions. So it's really important that all four of these things are present.